How to make amazing graphs in science. In your table of contents, you're going to write graphs and the page number. You're going to print out the graph paper. The link is in the notes assignment. Cut out one of the graphs. Save the rest. We'll use them in future experiments. On your notes page, write the word graphs at the top of the page. Using 5 tiny drops of glue, glue your graph onto the bottom of your notes page. Make sure there is room at the bottom to label your graph and write the numbers. Let the glue dry, and now we're ready to take notes. How to set up your graph. So the vertical axis is your y-axis. This is for your dependent variable. Your dependent variable in your experiment is the one that you're measuring. Your horizontal axis is your x-axis. This is for your independent variable. This is the thing in your experiment that you're going to change. Your data should cover 50% of the graph area and it needs to be accurately placed. So when you're looking at your graph, when you're looking at setting it up, if you have a certain area that I've either given you or on your paper, you need to make sure your data covers the whole graph. If you just do a very little bitty graph, you will get points off. So usually we remember the 5 things that we need in a graph by remembering the word tails. Tails will help you remember the 5 things that are essential in a good graph. T stands for title. The title explains the purpose of the graph. What is the graph about? The A stands for axis. So your y-axis is your dependent variable. What did we measure? The number of arm bends in our experiment that you should have finished. The x-axis is your independent variable. This is what did you change? And in this case, in our experiment, you changed time. The S stands for scale. And the scale is essentially how large is your graph going to go. What's your smallest number and what's your biggest number? And you usually go a couple of digits above it and below it. For example, here's how we would determine scale. If this was my data, who the favorite superhero teachers were, I would look at my lowest number and my highest number. And in this case, the scale would be from 2 to 22. Please, after you've copied the notes into your notebook, use your muscle fatigue data to determine your scale. So from the lab that you finished, you're going to determine your scale. Look for your lowest number and your highest number. I stands for interval. The interval is the amount of space between one number and the next. Are you going to go by 5s? Are you going to go by 10s, 100s, 3s? The interval is just as important as the scale. You want an interval that lets you make the graph as large as possible for your paper and data. For example, the interval is decided by your scale. So if I'm looking back at that example, and I know that my scale is 2 to 22, and I need to fit it into the graph. So I'm going to count how many lines there are on the graph. There's 5. I'm going to divide my top number by the number of lines on my graph. So 22 divided by 5 is 4.5. I'm going to round roughly to the nearest number, so whole number, which is 5. So the interval on this particular graph I would go by 5s. So 0, 5, 10, 15, 20, 25. After you've taken the notes, use your muscle fatigue data to determine your intervals. In this case, I believe it was, the top number was 54, and so I just divided it by the number of lines, which I believe is 16, and I ended up with going by 4s. Notice on the bottom, I also have the time in minutes. This one, because there's enough room, I'm just going by ones. So please set up your graph. The L stands for labels. You need to make sure you label your bars and all of your data points. In this case, the 5 superheroes. The bars have a general label. So what's the overall label of this? What do these bars mean? In this case, superhero. And then you're going to label your y-axis. What do those numbers mean? In this case, it means number of teachers. Make sure you always have the title, axis, interval, labels, and scales correctly. Not only does it make for a good readable graph, but it's also 5 of the things that I'm going to be looking for when grading graphs. So when do we use different graphs? We use bar graphs when we are comparing items. When we want to compare, let's say, how many people like or chose the hamburger over the hot dog at lunch. It makes generalizations about our data, and it helps us to see differences. Line graphs are for continuous data. We tend to use line graphs in science more than we use bar graphs. They are very useful for showing trends over time. And circle or pie graphs, we use them to show the percentage of the whole. Make sure you use your data from your muscle fatigue lab and you create a line graph. Remember a line graph, you're going to plot your data points, and once the data points are plotted, you will then connect the dots using a straight edge ruler. So when we look at data in graphs, we're looking for patterns, or what in science we call relationships. So what patterns or relationships can we see in the data? Positive relationships are when both variables are going in the same direction. Notice when I say IV, DV on the notes, it means independent variable and dependent variable. Negative relationships in graphs mean when one variable increases, the other decreases. So over time, this particular, let's say, stock is declining in value over time. Sometimes we don't see a pattern, and those are called null relationships. So what kind of relationship do we have in our notes? So one of the things you can do is you can draw a line kind of to get the general trend. And in this case, it's going from high to low over time, which means that there is a negative relationship. Please take a picture of your notes, put them in the file, and submit them for a grade.